God bless you, geometry students, and may His Spirit guide us as we do this review. It's going to be a sample quiz for the upcoming quiz 3, and I'm confident that you should be able to do very, very well on this. Remember what I taught you very, very early in the year, that with God, nothing shall be impossible. So here is this sample quiz, and for the first 3 questions, the instructions are: use the diagram to determine if the statement is true or false. And we've been through this in class, but just now again, to make sure it sinks deeply into your hearts, we have points B, C, and D are coplanar. Here we've got B right here, we've got C, and we've got D. And as you can see, each has got its little dot, and it's shown in this plane called P. So yes, these 3 points are coplanar, so there would be a resounding yes for this one. If we had, let's say, points CA and let's say another point on this plane Q up here, then certainly those would not be coplanar unless we make a very special plane having AC and another point here. But the second one says point A is on line L. So here is point A over here. Clearly point A is in this plane here called P. And when you see a capital in a plane without a dot beside it, that's the name of the plane. So A is in plane P, certainly not on line L. This is line L right here. It's point B that would be on line L, and this same point B is also on line M. So this one would take, I'm going to write no, but it should be false. For the first one also, let me change that to true. How about this one? Planes P and Q are perpendicular, and it's a good example here. You see plane Q here, this plane which is somewhat vertical, standing up, and plane P, more horizontal. The answer is going to be true for this one, because here is our sign of perpendicularity, or our sign which says that these planes are at right angles to each other, and the sign means true, they are perpendicular, or they intersect at a right angle. So that takes care of those. Numbers 4 and 5, I'll go to the next page so we'll have room for these. In fact, I'll go to the next page afterwards, but let's just do these 6 and 7 while we're on this page. Instructions: use the property to copy and complete the statement. So the first property we're going to be looking at will be the subtraction property, and this simply means that we subtract the same thing from both sides. So they're saying if AB is equal to CD, and I'll write it over here, AB is equal to CD, and this is just like an equation. If you would write an equation and you would say 3x equals 15. Then you could subtract the same thing from both sides and still maintain the equality. So in this case, we see EF being subtracted. But if we subtract it from the left, then what? By what I call the principle of justice, it has to be subtracted from the right as well. So the answer here should be AB minus EF equals CD minus EF. That is the subtraction property. Okay? So in here you put your AB, and here you'd put your CF. How about the transitive property? Transitive property, maybe you can remember this. Transitive means you're going to have three elements involved. So it says if A equals B and B equals C, then we can cross over and say A equals C. So that's what this should be. A equals C. We're going to be using that quite a lot, as I told you before. And number 8 here, how does John 7:24 helps us to properly understand diagrams? Well, John 7:24 tells us that we should not judge according to appearances. For example, going back to this diagram here, we could be tempted to say, well, this plane is upright vertically and this plane is horizontal, therefore the planes must be perpendicular. And yes, they could be, but don't go by just what it looks like. We have to have this little box, this perpendicularity marker, before we know for sure that they're perpendicular. So we look for a mark. Just like when Jesus comes back, we will be looking for marks, and I'm sure he'll have those marks in his hand from the nail prints and the spear mark in his side where the spear was thrust through his side to indicate or to remind us that he loved us so much that he is the one, not another, with those marks. So we have to be discerning to properly understand not only, of course, our Savior, but also to understand diagrams. Now let's take a look at numbers 4 and 5. Here's number 4. We're going to solve this, and then we're going to give a reason for each step. So I'm sure you probably already know what to do with this. This first one, we want the x to be by itself, because at the end we want to say x is equal to. So the first step is, since we have a plus 20, we're going to have to subtract the 20. We have to do the opposite, as you know. And when we do that, the 20 will be gone from beside the x, so the x will stand by itself. That's what we want. X is then going to be equal to 35, take away 20. That's going to be 15. And this is where we write the reason we got to this point. The reason we got to this point is because of the subtraction property. Subtraction property. And remember to write the prop. I know you might be inclined to just make it short and too sweet, but do a complete job and write subtraction property. That's all for that one. And here's number 5, a little bit more complicated, where we've got a variable on the left, namely 5x, variable on the right, 3x. So what do we do with that? Well, we want to have the variables on one side and the numbers on the other side, and usually we keep the variables on the left hand side. So we have positive 3x over here, positive 5x understood over here. So let's subtract the 3x from this side. But if we do it on the left, again, by the principle of justice, we have to do it on the right as well. This will be gone, and 5x take away 3x will give us 2x. We also have a 14 on the left, so we have to maintain that, equals 16. And now, having the variable on the left, we want to move the numbers to the right. So this being a plus 14, we're going to do the opposite to get rid of it from the left hand side. So that's what we do by subtracting 14 from both sides. That will be gone. So we have 2x is equal to 16, take away 14, that would be 2. Now I'm seeing that I copied this wrong. It should have been a minus here. So maybe I could change it here. It should be a minus 14 here, minus 14 here. So instead of subtracting 14, I would add 14. In adding 14, then I don't get 2, I get 14 plus 16 will give me 30. And in my final step, I'm going to divide both sides by 2 to get the x isolated by itself. Divide this by 2, divide this by 2, and I end up with x equals 15. Let's go backtracking now to find out what we've done. To get from here to this point, I had to subtract, so that would be the subtraction property. Next, to get from this point to this point, what did I do? I added 14 to both sides, so you write addition property. Finally, to get from 2x equals 30 to x equals 15, I had to divide both sides by 2. So I got to this point by what is called the division property. So that takes care of that one. And I've got another one here which is fairly long. I'd like to do that one with you before stopping this, and you can watch it on Edmodo. So whenever you see parentheses, it means that that's what you're going to do first. So I'm going to take the positive 4 and multiply it by everything in the parentheses here. So it's going to be a positive 4 times a negative 2x. And whenever I multiply a positive by a negative, I always get a negative result. So that's negative 8x. And now a positive 4 by a positive 3, the answer will be positive, and that would be 12, plus 5x equals 7x. I'm not touching anything else. I'm going to do the distributive property here again. Negative 5 times positive x. Again, when the signs are different, the answer is going to be negative, so that's negative 5x. And finally, negative 5 times negative 6. The signs are the same, so the answer would be positive. Okay, so let me just go ahead and put here the distributive property is what I used. And now, to proceed further, I have a term in x here, another term in x on the left, so let me put these together, these two together. I'm going to put negative 8x together with a positive 5x. It's going to give me negative 3x. The 12 doesn't have any term that is like it, so I'll leave it as is. On this side, I have 7x and 5x, which are like each other. 7 take away 5 is 2x plus 30. And now what I've done is I've combined like terms. Couple more steps. Got variable on the left, here got variable on the right, namely 2x. And in order to have the variables on one side, I'm going to subtract 2x from the left and from the right. When I do, this gives me a negative 5x, because when I'm adding and the signs are the same, I get a bigger number carrying the same sign. Plus 12 equals 30. And now I have the variable, namely 5x on the left. I want to put the numbers on the right. So this being a plus 12, I'm going to do the opposite. So I subtract 12 from both sides. That is gone. So this gives me a negative 5x is equal to 30 take away 12. That's going to give me 18. And finally divide both sides by negative 5. I get x equals positive divided by negative would be a negative 18 over 5. So these are the steps. In order to get from here to here, I had to subtract. So this is the subtraction property. And to get from Here to the end, I use a division property. All right, so that will give you a good exposure and I trust a better understanding of how to not only solve an equation but to explain what you've done. This is going to lead us into deductive reasoning, which will be the next topic we will be covering in geometry. So do your best to understand this well, and remember, with God, nothing shall be impossible.